Hi AB Calculus students. Here we are working on 2009 question number 5. It's a table question. You've got a quiz later on this week. 1.5 out of the 3.5 questions are table questions. Alright, something that happens on almost every table question. They ask you to find f prime 4, and there's not even a f. This is x and f of x. F prime 4. But here's the thing. They actually don't ask you to find f prime 4. They ask you to estimate f prime 4. Now I've explained this already several times in many videos. I'll just do it really quickly. Okay? If I was to find the actual f prime 4, it would mean find the slope of the tangent line through one point. The slope of the tangent line at one point is what the derivative means. That's the derivative at 4. It's the slope of the tangent line. However, if we're asked to estimate the slope of the tangent line and we can't use one point, we can estimate the slope by using 2 points that are nearby. So that's what we're doing here. Notice 3 and 5 both surround the nice number 4 we're trying to find. So we're going to find slope. Remember, when you're finding old school slope, you must subtract the y's on the top and the x's on the bottom. This is crucial. I still have BC Calculus students messing this up half the time. The y's, these are the y's on the top. So negative 2 and 4. And I'm subtracting y2 minus y1. So negative 2 minus 4, and then 5 minus 3. Now the great news is we actually don't have to simplify it. Can you simplify it? Yes. Do you have to? No. That's the answer. You're done. If you simplify it and you mess up, you lose points. That's a beautiful answer. If you want to make it negative 6 over 2, which changes to negative 3, great. But no extra points. All right, let's go to part B. So for part B, they ask us to do something rather strange, but we've actually done this before on a previous question. Integral to 13, 3 minus 5 f prime x dx. Okay, we've done this before. We've actually done something like this before if you go back and look at one of your earlier table questions. The first thing is I want to take the antiderivative, and I know something very simple. If somebody says, what's the antiderivative of f prime x? From 2 to 13, I can take the antiderivative of f prime x. The antiderivative of f prime x is f of x. And then I can plug in a 13 and a 2. You plug in the top and the bottom and subtract. This is important. This is going to happen somewhere in our problem. And then I can look up, oh, what's f of 13? It's a 6. What's f of 2? It's a 1. So I'm going to have to utilize this somewhere in our problem. But I can't because it's all stuck in here. So I'm going to separate things out. I'm going to distribute the dx so it belongs here. Okay, and I'm going to break this up. Now when I break this up, you see this 5 here? I don't need that 5 to be there, just a constant multiplier, so I'm just going to slide the 5 here. Okay, so let's start with this one. Well, what's the antiderivative of 3? 3x. And then we plug in the top and the bottom and subtract. So I get 3 times 13 minus 3 times 2. Now you don't even have to simplify this, okay? You could. That's 39. That's 6. You could subtract and get 33. But you could also simply leave this and don't do anything. Now, here we have a minus 5, and the antiderivative of f prime x is f of x. I'm going to plug in the top and the bottom and subtract. Where can you make a mistake? This minus sign or this minus 5 belongs to everything. So one thing you could do to be safe, if you ever have a minus in front of the integrals, you can just put a nice minus sign here that's going to belong to everything. And in fact, I can just pull the 5 out. A minus and a 5, that'll be multiplied. And I plug in this and this. F of 13 minus f of 2. However, if you're unsure, you can put a negative 5 in front of this one, and then minus a negative 5, which actually turns into a plus 5 in front of this one. So I'm not simplifying. Here I have 3 times 13, 3 times 2. I have this negative 5 now belonging to this minus this. Again, this is a 6 from the chart, and f of 2 is a 1. If you wanted to simplify it, great. There is no reason to. You know, that's 5. 5 times 5 is 25. This was 33 minus 25, which is 8. Yeah, the answer is not even 8, it's 18. I don't even know. that's why we don't simplify. But anyways, I think I did all the correct work there. And, oh, it is 8. Yes, I did it. It is 8. It is 8. Wonderful. All right, let's go to part C. I was looking at the answer to part C, and I thought I messed up. All right. Part C. Use a left-hand Riemann sum to estimate the area. Oh, yes. I hope they give us this. Let's get some points. Left-hand Riemann sum. So with left-hand Riemann sum, when this is the base, you choose the one on the left for the height. So I say, how far is 2 and 3 apart? That's a 1. And then I use the height on the left. So 1. I go to the next rectangle. How far are 3 and 5 apart? 2. The height, pick the one on the left, the 4. I go to the next one. That's a 3 with the height of -2. So 3, height of -2, and then a 5 with a height of 3. Don't simplify it, you're done. If you simplify it, I think you get 18, or that's what it says on here. I don't know. I'm not simplifying it. Okay. And now let's go to part D. Part D is actually worth 4 out of the 9 points. So you might think, oh, with D, it's the hard one. It's only worth 1 or 2. Well, sometimes the hard one's only worth 1 or 2, and sometimes it's worth like all the points here, it feels like. Okay. So for part D, suppose f prime 5 is equal to 3, and the second derivative is, okay, concave down, okay. Use the tangent line of the graph at f, x equals 5. Okay, wow, okay. So let's look at what they gave us for part D. Okay, and there's 2 parts. We're going to start in the section called tangent line. Okay? To write the equation of a tangent line, you need a point and a slope. So my point at x equals 5. When x is 5, my point is 5, -2. And my slope, f prime 5, they tell me is 3. Write the equation of a tangent line. Y minus y1 equals m, and then x minus x1. Now, you might not know what to do with your tangent line. They said tangent line. I wrote a tangent line. That's a point. Now, they want us to show f of 7 equals 4. Whoa, f of 7 is less than or equal to 4. What in the world does f of 7 even mean? F of 7 means what's the value of y when x is 7. So we're going to go ahead and simply make the x a 7. So 3, I put a 7 there, 7 minus 5, and I'm going to move this plus 2 to the other side with a minus 2. So I went ahead and replaced the x with a 7, so instead of calling this y equals, I could call this f of 7. And if you work this out, here this is a 3 times 2, 3 times 2 is 6, 6 minus 2 is 4. Wow, the other 4, I have no idea, my hands are not obeying me. So I got f of 7 is greater than 4. They want me to show that the true f of 7 is less than or equal to 4. Well, how are we going to do this? They told us that the second derivative is always less than 0. Now, what does that mean? That means the graph is always concave down. If the second derivative is negative, it's concave down. So look what happens when I draw something that is concave down. We used a tangent line at 5 comma -2, so here's my tangent line at 5 to estimate what happened way over here at 7. Well, way over here at 7, this is the real answer, but this is our estimate. So as you can see, our estimate of f of 7 is actually greater than the real answer we would have gotten of 4. You don't know what this actual answer is, but if our estimate, go back and look at this. Sorry. If our less than or equal to, I'm so sorry. I apologize. My estimate for f of 7 is 4. That's my estimate. My estimate is actually below. This is the real one. The real f of 7 lives here. This one, use the tangent line, was just an approximation. So my approximation was 4 was actually bigger than my real answer. So 4 is bigger than my real answer. So you would say, because the second derivative is less than 0, tangent lines are, and what type of estimate is this? Overestimate. Alright, and now the second part of part D asks us to do something you might never even heard of. It's called using a secant line. Okay? So what in the world does it mean to find a secant line? Now we've talked about it, that doesn't mean you remember it. Remember, our graph is still concave down. A tangent line goes through one point. A secant line goes through 2 points. So let's go ahead and see. They want a secant line on the interval 5 to 8. You see they say on the interval 5 to 8, 5x, 8. Well, let's look at the point here. The point here is 5 comma negative 2. And over here the point is 8 comma 3. Now, what do I need these for? Well, if I want to write the equation of a secant line, remember this is a secant line. A secant line goes through 2 points. You need a point and a slope. Well, we have 2 points to choose from. We don't have a slope. So I'm going to find slope by simply subtracting the y's on the top. So 3 minus negative 2, and the x is on the bottom. And when I do this, I get 5 over 3. And now I can write the equation. I'm going to take one of these points. I'm going to take this point and this slope and write the equation of the tangent line. Y minus y1 equals m, which is 5/3, and then x minus x1, which is an 8. So I used that point and that slope. I could have used that point and that slope. And the same thing happens in this question. They want me to approximate what happens if I plug in 7. So I'm going to do the same thing. Here I have a 5/3. I'm going to put a 7 there. And I'm going to add this 3 to the other side. So this right here, this y, is my estimate when the x was 7. So we're going to call this f of 7. And again, it was an estimate, so it's approximately, and listen, if you work this out, if you took the time to work this out, you would get what they told us, 4/3. This estimate, if you put this in a calculator, or just use your, well, if you do some fraction stuff, is 4/3. Well, the question is, how can we show that the real answer of f of 7 is above 4/3? Well, let's go back to the graph here. We found an ordered pair here on the secant line, but here's where the real f of 7 is. The real f of 7 lives here. Our estimate lives here. You will see that the real f of 7 is above our estimate. So because of that, we can say this, the real answer, is greater than this because secant lines are overestimates. Now, why is it an overestimate? Well, we've never talked about this ever in class. But if tangent lines dealt with concavity, and the only thing they gave us is concavity, let's just go with concavity. So because secant lines are, wow, I apologize. The secant line is not the overestimate. The secant line, sorry, here's the real curve. The secant one is actually below. Secant lines are underestimates because, and the only thing we know about the problem is concave down. So when a graph is concave down, secant lines are underestimates. And I don't think that's going to be on your test, but secant lines, there you go. Tangent lines, yes. Secant lines, probably not. All right, thank you, bye.